Lesson 1.4 is on properties of real numbers. So if you look on page 23, a couple vocabulary terms here. One is equivalent expressions. Equivalent expressions have the same value for all values of the variable. So one way to think of equivalent expressions is that they are things that if you simplify them, they're equal to each other. So for example, 9x plus 2x and 11x, those are equivalent expressions because really 9x plus 2x, if you combine that, is 11x. So basically for either one of those even original expressions we had, you could put a 0 in for x, you'd get 0 both ways. Go back to the original expressions. If you put a 5 in place of x, you'd get 55 both ways. Whatever number we put in, we're going to get the same thing if we have equivalent expressions. A lot of what we're going to be focusing on in this section is going to deal with properties. So commutative property. Commutative property works for addition and multiplication. And it says that if we have all addition or all multiplication, then the order of the numbers can be changed. So for addition, in the book it says 18 plus 54 equals 54 plus 18. That's great, but that doesn't really convince me that I need to know this. So I'm trying to give you more convincing arguments here. If you have three numbers, let's say 18 plus 23 plus 82, we can change the order of those, make it 18 plus 82 plus 23. Reason for doing that, 18 plus 82 just happens to be 100, and then 100 plus 23 is 123. It makes it an easier problem if we rearrange it that way. For multiplication, let's say if we have 5 times 37 times 20, I'll be working that one off to the side. Commutative property says, wait a minute, it's all just multiplying. We can change the order if we want. We can make it 20 times 5 times 37. That's a lot nicer because 20 times 5 is 100, and then 100 times 37 is 3,700 or 3,700. Okay, so I know those are pretty dramatic examples, but that's the commutative property. A way to help you remember the commutative property, I heard once somebody said, if you look at the first two letters in commutative property is CO, change order. Okay, so commutative property, we can change the order of the numbers. Another way to think about commutative property, if you commute, commuting you might think of as driving back and forth from one place to another. So they talk about people commuting to work. So when you go there, when you come back, the order of the things you pass is going to be different. It's going to be pretty much opposite if you go the same route. Okay, it doesn't have to be opposite, just understanding that it's in a different order. Just like when you commute to and from one place to another, on the return trip, it's going to be a different order. Okay, or you can just think of CO, change order. Associative property also works for addition and multiplication. And it says if everything's being added or everything's being multiplied, then the grouping symbols can be moved. So we can move parentheses or brackets or braces, things like that, if everything's just being multiplied or everything is just being added. So rather than recreate the wheel, I went with very similar problems here. So you can see that first example in the multiplication, I just moved the parentheses. The second one, same thing, moved the parentheses in order to make it easier for me to multiply. Just a way to help you maybe remember this, associates are like people you work with. So you may have heard a little jingle before. There's a commercial for Robert John and Associates. So just think about it. It's a person and some other people that he works with. Okay, so associates, people you're grouped with. So think of associative property as the grouping symbols are moving. Page 24, a few more properties. Some of these we're not going to worry about too much. I will mention them, but identity properties. Identity property of addition says if we add 0 to a number, then we get the same number we had. Multiplication identity says if we multiply a number by 1, we get the same number that we had. 0 property of multiplication says if we multiply a number by 0, we get 0. And multiplication property of -1 says if we multiply something by -1, then we'll get its opposite. So like I said, I will mention those. We're not going to worry about those too much though. So if you look at problem 1 part, we'll just look at part B. A is the 0 property of multiplication, but part B, if you'll notice, they moved the parentheses, and so that's the associative property of addition. Part C, that would just be the identity property of addition. Again, not going to worry about that too much. The got it one, that's the identity property of multiplication. And then if you look at part B, temptation when you look at this might be that you're seeing these parentheses and you might be thinking about a property that has to do with that, but actually what's happening, if you look closely, what happened is they moved the numbers. They changed the order of the numbers inside the parentheses. So they changed the order. That's the commutative property. Okay, or commutative property of addition, you could say. If you look at problem 2, they're just talking about how we can potentially do problems differently. That makes it easier for us to figure things out, possibly in our head, although I'd prefer we work it out pencil and paper just to be safe. So on problem 2, we've got movie tickets, drinks, and popcorn. What's the total cost? So they started out, they really wouldn't have needed to have these parentheses here. We're just adding 3 numbers together. So just think about which of these would be easier to add together. So the 775 and the 125, those would be easier to add. So we can change the order. We can use the commutative property if we ignore the parentheses that we don't really need. Change the order with the commutative property, add those together would be $9 plus $2.40 would be $11.40. Got it to a can holds 3 tennis balls, a box holds 4 cans, a case holds 6 boxes. How many tennis balls are in 10 cases? So we just kind of work our way up. We've got 3 tennis balls in a can, and a box has 4 cans, so that'd be 3 times 4. You could go ahead and work that out if you want. So that would be the number of tennis balls in a box, and then a case has 6 boxes, so we could multiply that by 6. And then for 10 cases, we'd multiply that by 10. So essentially, we're going to have to multiply all these numbers together. I kind of like the 10 being at the end, so I'm just going to leave it there. And it says mental math, but, you know, we can work this thing out probably just as well. Okay, so you work it out, it would be 720. And technically, we're just multiplying all the numbers, so you could actually get by 3 times 4 is 12, 6 times 10 is 60, and then 12 times 60 is 720. Okay, if they're all just being multiplied, then it doesn't really matter what order we multiply them in. Next thing we're looking at is writing equivalent expressions. So if you look at problem 3, part A, 5 times 3n. The book talks about using these different properties. You could think of 5 times 3n as we've got 3n plus 3n plus 3n plus 3n plus 3n. Essentially, what we can do, we can think about just multiplying these numbers together. So 5 times 3 is 15, so 15n would be what we would have all together there. Part B, these are all just being added, so we don't really need the parentheses. So really we could just look for like terms to combine. You can see 4 plus 8. Those would be like terms. 4 plus 8 is 12, so 12 plus 7b, or if you rearrange it, 7b plus 12 would work. On part C, actually everything's being multiplied in the numerator, so those are all factors. If you wanted to, you could put parentheses around those just to show everything's being multiplied. So we can reduce like factors, just like reducing a fraction. We can reduce those by a factor of y, and then we would be ending up with 6x for that problem. So if we look at the got it 3, part A, we're trying to simplify this expression. So to simplify this, we would be multiplying these together. So if we multiply those and then add them together, we've got a total of 2 numbers after the decimal point there. And then we can put an x after it, so that would be 9 and 45/100ths x. If you get a lot of those problems like that, we could do it on the calculator just to make it quicker, but understand on your test you're probably going to need to use a calculator for those. Part B, once again, everything's just being added, so really if it's all added we don't have to have the parentheses here. I know they're wanting us to use these properties, but 6 plus 3 is 9, so 9 plus 4h or 4h plus 9, either one of those would work. And then if we look at part C, everything's being multiplied, so we can reduce the m's, the factors of m. And then also actually the 8 and the 12, we can reduce those down. We can divide both of those by 4. So 8 divided by 4 is 2, 12 divided by 4 is 3. So we've got 2 over 3n. So the next thing they're talking about in your book is deductive reasoning, and that's a process of reasoning logically from given facts to a conclusion. So it's kind of like we look at the facts that are happening and then we come up with the conclusion based off of those things. If something's not true, then we can give an example showing that it's not true, and that's called a counterexample. So if you look at problem 4, they're asking if this is true or false. If it's false, give a counterexample. So part A, it says for all real numbers a and b, a times b equals b plus a. Well, if you multiply numbers and you add numbers, you're not always going to get the same thing. So that would be false. A counterexample they give, 5 times 3 is not equal to 3 plus 5. 5 times 3 is 15. 3 plus 5 is 8. So that does not obviously always work. Part B, for all real numbers a, b, and c, quantity a plus b plus c equals b plus the quantity a plus c. Basically, we're adding the 3 numbers, same 3 numbers on both sides of the equation. So that would be true. And the book's showing we can use our properties, commutative and associative properties, to show, rearrange and show that those are exactly the same. So if we look at the got it 4, is each statement true or false? If it's false, give a counterexample. If it's true, use properties of real numbers to show that they're equivalent. One thing you can do on these sometimes is try and simplify them. So for part A, if you look over on the right side, we've got k plus 0. K plus 0, that's not changing anything. K plus 0 is still k, so that would be k times j. The other side we have j times k. It's just a different order. We're just multiplying the same numbers together, so that would be true. Part B, for all real numbers m and n, m times the quantity n plus 1 equals mn plus 1. So what we could do on these, one thing would be we could use the distributive property. So that would be m times n plus m times 1. So that'd be mn plus m. The other side we had mn plus 1. So this is not always going to be the same. If m equals 1, then it would work, but otherwise those are not going to be equal, so that one would be false. And part C, they're wanting us to go back to problem 4, not number 4, got it, 4. So it's asking if that's false for every pair of numbers A and B. So that's going back to this one, A times B equals B plus A. So we proved that this was not always going to work, but the question is, will it ever work? And the answer is yes. One thing would be if A equals 0 and B equals 0. If they're both equal to 0, 0 times 0, 0, 0 plus 0 is 0. So that would be one thing that would work. Another thing would be if A equals 2 and B equals 2. 2 times 2 is 4, 2 plus 2 is 4, so that would work as well. So if we look at the lesson check number 1, we've got x plus 12 equals 12 plus x. So they're wanting us to tell what that property is. Think about what happened there. They changed the order, change order. That's the commutative property. Okay, it's commutative property of addition, we could say. Number 2. So we had over here, parentheses around 12 times x. Over here, parentheses are around the 5 times 12. So that would be the associative property. We changed the grouping. Okay, so associative property of multiplication. If we look at number 4, trying to simplify that. Basically, those are all factors, and so we can reduce those both by a factor of c, or you could say divide by c on both of those, numerator and denominator. And we get 24d over 1, which is the same as just 24d. Number 5, they're wanting us to tell whether those are equivalent. So 5x times 1, that's the same as 5x. And we can't really simplify over here. I mean, you can rearrange that if you want, I guess. But so if we have 5x and you have 5x plus 1, are those going to be equal? And the answer is no. So we could say no, or if you go back to the wording we used earlier, you could say false, I guess. And then part B, parentheses we don't really need on this first one in part B, so we can look for some like terms. The ones we can add together, 1 plus 1 is 2, so 2 plus 2t, and the other side we have the same thing, and so we could say yes, those are going to be equivalent. So this gives you an idea of how to work with some properties of real numbers. Have a good day.